In this video, I'm going to show you the separation of variables method. Later on, I just call this as SVM, okay? SVM, which is stands for separation of variables method. Okay, I hope that you still remember what we have done in our chapter 1, because this method is quite familiar to us because you see you have separation of variables. The word separation is must be familiar to us because in chapter 1 we already been given the 4 types of equation where one of the equation is separable equation. Okay, so this method, the SVM, is closely related to SE, separable equation. But okay, the difference is just during our separable equation in chapter 1, okay, you're given like y double prime, which is your dy dx, okay, plus 2xy equals to 3x squared minus 1. Okay, you know that this is a linear equation in the form of ay prime plus by equals to c, okay, or y prime equals to p y prime, okay, plus py equals to q. Okay, so this equation in the form of uh, linear equation, and this is a linear equation, and you try to solve for this one, this equation, and then the solution that you want to find is y as a function of x, remember? Okay, so that is the first order linear differential equation. Okay, and notice that you have dy dx where you have y as your dependent variable and x as your independent variable. Okay, means that what I want to tell you is you have one independent variable only. But for SVM is solved for partial differential equations. This one is differential equation, chapter 1. But for SVM, it is solved for partial differential equation where you have more than one independent variables. You get the idea? Okay, so that is the concept of separable equation in chapter 1 and separation of variables method in chapter 5. Okay, consists of one independent variable, more than one independent variables, you have dy dx. But in this chapter, we are not talking about dy dx. We will talk about del. Del of what equals to del of what. So, for example, del u del t, which means that your u here, your dependent variable, consists of more than one independent variables. Okay, which is one of them is t. Okay, so you have more than one independent variables. Okay, so now SVM, as I said just now, SVM is solved for PDE. So what is your PDE? PDE is this one in the form of alpha u sub t equals to beta u sub t, where alpha and beta are constants. Alpha and beta are constants. Okay, I will note this one as Q. Okay, this is your PDE actually. This is your PDE, partial differential equation, the equation of partial differential. Okay, I note this as your Q, which is your question. Okay, in examination, this is your question. Okay, you are given this one as your question, and then this PDE, this question will come together with boundary condition. Okay, right here. Okay, u sub t equals to beta u sub x. This is equivalent to alpha del u del t equals to beta del u del x. Okay, so just the same thing because this is just the mathematical notation. Okay, this PDE will come together with the boundary condition here. Okay, boundary condition. Your boundary condition is given by UAT equals to any function of t, any function of time lah. Okay, so I want to note this as your Q, your question. Okay, and this is your boundary condition. Okay, so perfect. You have question and the boundary condition. You have an equation with the boundary condition and how to solve for this one. Okay. We will discuss how to solve later. Okay, but what I want to tell you, the most important part here is you already get the solution. Okay, I note this as S. Your solution is U x t equals to x dot t, where your x is a function of x dot with t as a function of t. So we call this as a product solution. Why product solution? Because you have the product of x and t. Okay, so jangan dia buat macam kalut-kalut ayam pula. Apa ni madam? We know the solution is you. How we get you? Alah, tak payahlah buat kalut. Okay, during our chapter 1, chapter 2, you have been given dy dx, d square y dx square. Then the solution you apply lah apa-apa method yang appropriate kan. And then at the end of the day, the solution is y as a function of x. So the same thing goes to your PDE. You are given del u, del t, del u, del x. So the solution that you wish to find is of course lah u. Kan? So tak usah nak buat kalut sangat, rasa macam susah sangat lah. Pang lagi. Okay? Kan dah bising tu. Okay. So that is your solution u. U ni, kalau before this, your solution is y as a function of your x, independent variable dalam ni. Okay? So the same thing here. U is your solution. Here your dependent variable. And then you have more than one independent variable. More than one independent variables, which are your t and x. So that is why your solution consists of x and t, your independent variables. Okay, and x dot t here is your solution. Okay, so in short, what I want to tell you is the PDE must come, the basic PDE must come with the boundary condition. This is your PDE and come with the boundary condition, and this solution is u equals to x dot t, where x is a function of small x and t is a function of small t. You got the idea? Okay, question, boundary condition and solution. The question now, how to solve for this one? How to solve? Madam, dah lah, saya faham lah yang tu. So the next question is how to solve the problem. Senang je. These are the steps to solve for PDE, but I don't want to discuss the step of solution one by one through the not the specific problem. I just jump to the specific problem here. Okay, later on you can try to relate with the previous explanation. Okay, previous slides. Okay, so now look. You have 2u sub t equals 2u sub x. This is 2 del u del t equals to del u del x. Okay, look. This equation, this is a PDE because you have del, and u sub t, u sub x represent your partial derivative, and when you have this one, so this is called partial differential equation. Okay, so in your PDE here, it is matched with our previous definition. The definition is alpha del u del t equals to alpha del u del beta del u del x. So alpha and beta are constants. So now alpha is 2, beta, your beta is 1. So match lah, kan? So we can solve this problem by using SBM. Alright, and then we look at here. This question come with your boundary condition u0t equals to 3e5t. So samalah ni, uat equals to gt. So this is your gt lah by definition just now. Okay, so next, how to solve for this one? We have question, we have a boundary condition. So now we want to find the solution. The solution is already found tau. What is the solution? The solution is u x t equals to x. Okay, x as a function of x dot with t as a function of t. Okay, madam, kalau dah ada jawapan kira buat apa? Okay, this is the standard solution. We want the aim here is we want to find what is your x and what is your t and then plug in into the solution. So that is the idea. You got the idea? Dapat tak? Dapat tak? So now our work is we need to find x and t. t. That's all. Okay. So now I want to tell you how to get the solution x dot t. Okay. So that is our work. So now the first step is in order to get the solution, you must begin with the solution. Apa benda tu? Okay, we want to find ni, this one, x and t. So you must start with the solution. Okay, solution of the SVM or the product solution. So look at your question. Your question asks you to find 2u sub t. I just remain 2. Okay, so now find u sub t. U sub t is del u del t. So I just write del t. My u here is the solution, which is x dot t. Like that. Okay. So I just apply the product rule. Okay. I remain x. This one is uv kan. Remain your v. U differentiate v plus remain your v differentiate u. Okay. Remain your u differentiate t of t with respect to time. Here. Small t. So this, when you differentiate capital T with respect to small t, that is not 1. Cannot be 1. That is dt here. Okay, because this capital T is a function of time. So you have dt plus remain your v, which is your t, differentiate x. Okay. If you still remember during our first discussion on the first part of video, when you have more than one independent variables, when you need to differentiate with respect to specific variable. So now we differentiate with respect to small t. When you differentiate with respect to small t, the other variables will be treated as a constant. Okay, which means that your x here will be treated as a constant. So you remain t, differentiate x with respect to t. You notice that this x is a function of small x. Tak ada t kan? We don't have t. So that is constant. So your x here is a constant. You need to treat x as a constant. So differentiate constant will give you 0. So that is your solution for du, del u, del t. This one. Okay, after this, the idea is we can plug into the question first. Okay. So next, 2. You need to find your u sub x. So the same thing, del u, del x is u sub x. Okay, del x equals, del x, your u is x dot t. Okay, remain your x, differentiate t with respect to small x. This t is a function of small t. You don't have x pun. So this t will be treated as a constant. Differentiate constant, give us 0. Okay, plus remain your t, differentiate x with respect to small x, where x here is a function of small x. So you have dx. Gitu je. So you have t dx dx for the second one. That is the first step. Okay. The second step is we need to substitute. That is our first step. So the second step is we need to substitute del u del t and del u del x into our question. Okay, substitute. So in question we have the left hand side is 2u sub t. 2u sub t is 2x dt dt equals to your right hand side here is u sub x. U sub x is t dx dx. Okay. That is the second step. The third step, since the name of this method is separation of variables method, so we want to separate the variables lah in order to get the solution. So try to separate the variables. I want to remain t on my left. Okay, so that I have 1 over t dt dt. Okay, I bring this t to my left. Okay, I want to keep t on my left, x on my right. So I just do like this. And then equals to, I bring 2, a constant to my right. Okay, half 1 over x dx dx. Okay, so the variables already separated. Okay, so the next step is, if you still remember, during our separable equation, after we separate the variables, then we can integrate, right? Okay, but in this SVM, before we integrate, look here, if you try to integrate directly, left hand side and right hand side of your equation just now, here you have 1 over t dt dt. So this is weird because when you try to integrate, you have 2 dt dt here. So the additional step is in step 3, after you separate the variables, okay? After you separate the variables, what you need to do is, okay, you need to equate your equation to negative k. Equate to negative k. Then only you can solve for integration. Okay, after you equate to negative 4, so I will try to divide this solution into 2. Okay, so I have 1 over t dt dt equals negative k. Sorry. And the other one is 1 over 2, 1 over 2x. Macam pelik pula. Okay, so I have 1 over 2x dx equals to negative k. Then only I can solve for this one. So solve these two separately. So like this and like this. So what I need to do is, again, I try to separate the variables because at your left hand side you have capital T, but this one is small t. Okay, this small t will be brought to your right hand side. So this one I have t 1 over t dt equals to negative k dt. Nah, then only you can integrate. Nampak? Dia dah tak weird dah. Okay, just now you have dt dt on your left. So macam mana nak integrate ni? Macam mana? So we integrate with with respect to one variable je lah. Okay, so this one the same thing. So I want to have 1 over capital X, only this one. Okay, so d capital X equals to negative 2k dx. Okay, so this is just a first order. So we need to integrate lah both sides of the equation. Then only we can integrate both sides of your equation. Sorry, this one. Okay. Okay, integrate both sides of the equation. This one and this one. Okay. Alright. So solve for this my left hand side first. This one. Okay. Integrate 1 over t dt will give us natural log t equals to negative k dt. Negative k is a constant. Okay. So negative k, I forgot to tell you. Negative k is just a constant. Okay. Constants of proportionality. Itu nama dia. Wah, nama dia kemain. Okay. So we have to integrate negative k dt. So negative k is just a constant. You can take out negative k out from your integrand here. So you have to integrate 1 with respect to t. So this one is negative kt, and don't forget to plus a constant c as your solution. Note that you have natural log t as your solution, but the target here, we just want to find t, not awak panggil apa, ln t not ln t. We want to find t, but you have the solution of ln t. So what we need to do is we need to take the exponent both sides of the equation. Exponent natural log gone, so you just have t equals to, you take exponent, this one is exponent negative kt dot, plus c equals to exponent negative kt dot ec. Okay, yang ini kita belajar during our form 4 high school. Okay, exponent c I just write as a, e negative kt is e negative kt lah. So this is my solution where a equals to exponent c. Nah, okay, so that is t. Then we can plug in into uxt equals to x dot t. This t here. Okay. But now we want to find what is x. So the same thing, integrate 1 over x. So you have natural log x equals to negative 2k. This time around not x and not t lah, because you have integrate with respect to x kan. So you have 2k x plus, let's say d, a constant. We don't want natural log x. We want x here as your solution. So taking exponent both sides of the equation, we have x equals to, let's say b, e negative k x. So I just skip the step. So you can recall this one. Rewind lah dapatkan yang ni. Okay, kalau tak ingat. Okay, so this is your x. Nah, we already found x and t. Then we go to the product solution. U x t equals to x dot t. Okay, x is be negative kx dot with your ae negative kt. So we try to simplify this solution. Okay, a dot b, a is a constant, b is a constant. Let's say you have f, a constant lah. So katakanlah b ni, let's say b is 2, a is 3 kan. 2 times 3 is 6. So your f. Okay, that is the analogy. So e is e. I try to factorize e. So I have e negative k. So x plus t. Agree? So this is our solution. uxt. I forgot this one. uxt. Okay. So this is the solution. This is our general. Okay. Sebut macam apa-apa kan. The general solution. This is your general solution. Okay. Now, this is our general solution. Now, look at the question. Okay. The question give you the boundary condition. Okay. When you are given the boundary, bukan yang ni. U0T, 3E5T. Okay, so after you get the general solution, then only we substitute the boundary condition to get the particular solution. So you have U0T equals to apa entah tadi? 5E2T Malas saya nak naik atas, so I just write 5E2T lah. Tengoklah kejap lagi you confuse kesian pula. Aku juga nak jawab tu kan. 3E5T lah. Aduh, dah tua betul lah lupa. 3E5T kan? Bismillahirrahmanirrahim. 3E5T. Alah, ini je lah saya tak nak patah balik dah. 3E5T. Baru je kejap patah, tengok kat atas tu saya dah lupa dah. 3E5T. Okay. So in order to get the particular solution, look here class, look here. The solution is uxt equals to fe negative k x plus t tau. And the condition that you are being given is u0t equals to 3e5t. 3e5t. Okay, when you compare the condition here, the condition with your general solution, you will find that x is set as 0. X is set as 0. Okay, so which means that x is here equals to 0 lah. Okay, in short, I can say that I just have equals to fe negative kt. Agree? When x 0. So fe negative kt. So I just compare lah. Okay, I compare, I find that f is 3. E is e. So k is negative 5. K equals to negative 5. Nampak tak? K equals to negative 5. So, the conclusion is my particular solution is u. Jangan masukkan 0 ni. 0, this 0 is your boundary condition. This is boundary condition. This is your general solution. So, substitute into your general solution. So, uxt equals to f just now is 3. E, k. K is the constant that you need to find, which is e negative, okay. So you have k equals to negative 5. So negative is positive lah kan. So 5x plus t. Okay, nampak? Alright. So this is your particular solution. Senang kan? Okay, first of all, given the PDE must come together with your apa tu nama dia? Boundary condition. PDE must come with boundary condition, and then you need to find the solution. So start the solution with uxt equals to x dot t. So this is what you need to find. In order to start finding the solution, look at the question and ask yourself, oh, this question 1 del u del x. So differentiate u with respect to x. What do you get? Equals to 3e5, 3 del u del t. So differentiate u with respect to t. Okay, after you differentiate, okay, and then substitute back into your question and equate to substitute into your question here, and then try to separate the variables. The step 3 is separate the variables and then equate to negative k. After that, try to split this equation into two, where you have your left hand side here equals to negative k, your right hand side here equals to negative k. Okay, and then you integrate both sides of the equation. Separate the variables, integrate both sides of the equation until you get what is your x and what is your t and what is your x. And then plug in into the product solution, u equals to x dot t. So that is your general solution. In order to get the particular solution, go back to the question where you have the boundary condition. Okay, and then you just compare x equals to 0, and then you just compare here to get the f and k. And then plug in into your general solution to get the particular solution. So that is separation of variables method. Later, we will discuss the heat and wave equation. Yang ni faham eh? Okay, thank you.